Hello, hello, hello. Okay, I think it is fine. So, okay, so hello, hello. Okay, okay. Yeah, so I think the voice is okay now. Just if you remember, uh, we have we for the low pass filter, for example, I have a circuit in which I have inductors and capacitors. So I have a circuit in which I have inductors and capacitors like that. So L1, L2, C2, R, something like that. Now, sometimes these circuit elements are difficult to fabricate or difficult to obtain at microwave frequencies. So we like to replace these by transmission lines. Now, how can we replace an inductor and a capacitor by transmission lines? We have to look at the input impedance of an open circuit and the short circuit transmission line of length lambda by of any transmission line is Z naught ZL plus J Z naught tan beta L divided by Z naught plus J ZL tan beta L. So uh, now what we do is we find the input impedance for an open circuit transmission line of length lambda by 8. So open circuit means ZL equal for to use the infinity at the in the denominator, we can use this one. So when we put ZL equal to infinity here, I get this equal to 0, and also this term equal to 0. So what I get here for open circuit is Z in is equal to Z naught 1 plus this all is 0 because of infinity, 0 divided by Z naught over ZL. This is 0 because of infinity, and this is equal to J tangent beta L. Now L is lambda by 2 and beta is 2 pi by lambda. So I have here Z naught 1 divided by J tangent 2 pi by lambda multiplied by lambda over 8. So this is, and this goes to 4. So tangent of pi by 4. Tangent of pi by 4 is 1 because it is 45 degrees. So I can just see that this is equal to minus J over Z naught. So it means that this is the reactance. Uh, yeah. So this is the negative reactance, which means that this is equivalent to a capacitance. So we can say that, yeah, so this is yeah, to the capacitance of the reactance of capacitor, which is 1 over j omega c. So this, if I make them the two equal, so and what I'm doing is I'm trying to find the equivalent capacitance. So this j cancels, and c is equal to c is equal to uh, Yeah, there is something wrong in the calculations here. Yeah, here, yeah, divided by 10. So, Z naught. Okay, this is correct. So C, J Z naught. Yeah, so this is Z naught divided by J. Yeah, this is uh, so so Z naught is in the numerator. So this is Z naught divided by J, or it is minus J Z naught. So from here we can see that it's a negative reactance. So this should be equivalent to some sort of capacitance. Now the capacitive reactance is given by this, so I can make the two equal to find the equivalent capacitance. So this will be minus J over omega C equal to minus J Z naught. So my inductance in the form of unity frequency. So at unity at omega equal to 1, this C is equal. Okay, so this is for the inductance, for the capacitance. I can so I can also now look at the short circuit impedance. Um, yeah, let me just delete some of this so I can find. So from this I can find. Yeah, so this is. So yeah, this is equal to J Z in is equal to minus J Z naught, and if I make it equal to XC, which is 1 J minus J over omega C, my C is equal to Z naught. Now for the short circuit, I can use the other. So where ZL equal to 0, so J Z naught 10 beta L divided by so Z naught. So what I will go next is I will go to the uh, one of the examples, and I can replace the inductance and capacitance by uh, the open and short circuit. So let us go to the example, one of the examples in the book. That is example number 8. And it is page number, and it is also given in the lecture. So if you look at lecture 8, which I just forwarded you before the lecture, you can look at this example. So this is page number 404. This is in sorry, this is it is after that. So it is page number. Yeah, it is page number. So this erase all that. So I can just write the summary here. So if I have an open circuit, if I have an open circuit transmission line of length lambda by 8, then filter, and this is one of the questions from your previous class assignment. So if you want to see the detail, you can look at there if you want inductance and capacitance. So now in this one, we need to find the low pass filter. I need to design, so this is example 8.5, and we can find that the unit elements for n equal to 3 are, these are given by 1.0.618. So I can find the inductance and capacitance as I did uh, in the class assignment. But for now, I want to find the transmission line equivalent. So what we do, I just draw the circuit first, in, and then so no, sorry, this is not the uh, yeah, sorry. So this is not this problem which I'm going, because I'm following the lecture. So let's do the one which is in the lecture. So in the lecture, I have uh, the circuit n equal to 5 circuit, n equal to 5. Yeah. So so yeah, let us look at the lecture 8 problem. So I have the low pass filter, and I think this is so maximally flat, and you can, for the maximally flat of n equal to 4, so n equal to 4, so I can go to the table of the maximally flat and get these. Yeah, so n equal to 5, n equal to 5 maximally flat. So the problem is n equal to 5. I can find these G1, G2, G3, G4, and G5. And these are given by 0.618, 1 point, which is 1. So this is my circuit. I want to apply these rules. So I can make just a small table. Uh, I have here uh, G1, so my unit values. So unit, this is 0.618, 1.618, 2, 1.618, then 0.618. Sorry, this is R naught. This is 1, and this is 0.618. This is 1.618. This is 2, 1.618, and then 0.618. Okay, now the next step is to find the impedance. This is 1 over 0.618, 0.618. This will be same because it is inductance. It will be 1.618. This is 1 over 2. This is again 1.618, and this is 1 over. So I can write the actual values here. This is 1, 1.618, because 1 over 0.618 is 1.618. This will be same. So this is the equivalent Z naught. This is 1 over 2, which is point. So I can now take this circuit and draw the equivalent circuit in terms of open and short circuit. So I have this transmission, this voltage source. This is 1. Now this will be equivalent to an open circuit line with this impedance. So I have, so this is an open circuit here. When you have, wherever you have capacitance, I will put an open circuit. And wherever I have an inductance, I will put a short circuit. Then I have a capacitance here, so I put an open circuit. Then I have again a resistor. So this is impedance of the first transmission line. This is open circuit. The length of this transmission line is lambda by 8. All of this is lambda by 8. 1.618. This one is also 1.618. This one is 2. Impedance is because of this inverse relation between inductance and capacitance. So this is my circuit if I replace all these elements by open and short circuit. So this is a very interesting situation now. So I don't have any, in this situation, if you look at this situation, it is a very interesting situation. I don't have any inductance and any capacitance in this circuit. So there is no inductance or no capacitance here. It is only open circuit transmission lines and short circuit transmission lines. But still, this is a low pass filter. So this is a low pass filter. And this is exactly equal to this. This is also a low pass filter. So how do I know that this is correct? The easiest way to do is it's to put this in NSOFT. So when I put this in NSOFT I can put the transmission lines as of this is equal to S21 of this. If it is same, then it means that our model, our transformation is good. So, but what is the advantage? The advantage is we don't have to buy these components. We don't have to, because capacitance and inductance are components, are expensive components. So by putting